Hi, my name is Eddie Bridgman, and my group has elected to speak about cloud computing. So, in layman's terms, cloud computing is when you use remote servers on the internet to manage, store, and process data, rather than using a local server or a personal computer. No longer must you be tied down by your own storage devices or desktop computer. No, now storing things can be as easy as just connecting to Wi-Fi. Cloud computing comes with a variety of benefits for the small and large users of its services. One of these benefits is what is known as pay-per-use, or metered services. This is when you have unlimited storage resources but only pay for what you are actually using. That makes this product a great tool to be used today. I mean, when you really think about it, it makes sense, right? No one wants to get into a cab and pay a flat fee regardless of their destination. So why be charged for storage needs that greatly trump that of what you really need? Because of meter services, companies are able to just purchase computing resources to match its fluctuating needs instead of maintaining a large network infrastructure that exceeds the company's average computing requirements, which saves them a ton of money, which you can imagine they were spending before. This is also very helpful in the consumer market, where internet service providers could charge a monthly flat fee for a subscription. Now they are just charging customers according to usage. Now that cloud computing is gaining traction, even an entertainment website like iTunes have joined, which is really popular with the younger market. Pay-per-use is by far one of the easiest benefits of cloud computing to understand.
Hello, my name is Dave Marcus said. I'm talking about cloud computing for this segment. Cloud computing is like where where apps and services be able to control their own things. So like cloud computing is like instead of having a local personal hard drive, it's like an imaginary hard drive where you can store all your documents and things in. Instead of having a visual one like in your house or by your computer, by your desktop that you'll plug in to get all your information off or put it on, exporting and importing it. So yeah, cloud computing is just like an imaginary hard drive that you could put all your stuff on, just like the cloud, or they could where like for Apple iPhones and MacBooks and stuff like that. They put all their things, all their documents and stuff on the cloud, and it stores it for you, keeps it for you instead of you having a visual flash drive or hard drive that you have to import and export your personal information and documents on. So yeah, that's pretty it for this segment of cloud computing. Not really much to say about it. I can say the same thing over and over again, but that's all it really comes down to for this part of the segment. Cloud computing just holds all your personal information documents on an imaginary hard drive for you instead of for you have to import and export them personally or initially instead of or you could lose your stuff. It keeps all your stuff for you. And that's really it for this part of the segment.
Hi, my name is Daniel Bullock, and I'll be talking about elasticity in cloud computing. Elasticity is defined as the degree to which a system is able to adapt to a workload of changes by provisioning and deprovisioning resources in an autonomic manner, such as to the point that each in time the available resources match the current demand as closely as possible. Elasticity is the defining characteristic that differentiates cloud computing from previously proposed computing paradigms such as grid computing. These dynamic adaptations of capacity, for example, by altering the use of computing resources to meet a varying workload, is called elastic computing. Elasticity aims at matching the amount of resource allocated to a service with the amount of resource it actually requires, avoiding over or under provisioning. Over provisioning, for example, is allocating more resources than required. Should be avoided as the service provider often has to pay for the resources that are allocated to the service. For example, if Amazon was to have an extra large instance, the cost of an instance would be 23 cents per hour. If a service is located to two virtual machines instead of one required, the server provider wastes $2,095 every year. Hence, the services provider's expenses are higher than optimal and the profit is reduced. Under provisioning, for example, is allocating fewer resources than required. It must be avoided. Otherwise, the service cannot serve its users with a good service. In the above example, under-provisioning the website may make it seem slow or unreachable. Web users eventually give up on accessing it. Thus, the service provider loses customers. On the long term, the provider income will decrease, which also reduces the profit. There are some problems for elasticity in cloud computing, such as a resource provisioning time. Elasticity does take time. It is not an instant reaction. For example, a cloud virtual machine can be acquired by the user at any time, but it will take up to several minutes for it to be usable. Cloud providers have a different virtual machine starter for each performance. This implies any control mechanism designed for elastic applications must consider in its decision process over the time needed for elasticity actions to take effect, such as providing another VM or virtual machine for a specific application component. There are other problems involving elasticity in cloud computing. These other problems are as followed: monitoring elastic applications for the benefit of avoiding complications of over or under provisioning computer resources and causing problems to the computer when you're running multiple instances of virtual machines or whatever possible applications that require elasticity in cloud computing, and elasticity requirements for the event that when you're attempting to use cloud computing, but neither the computer nor the virtual machine are able to do it due to systematic circumstances.